بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. This is the lecture number 4 and the last lecture in the introductory chapter, Introduction to AI and Data Science. And today we're going to talk about the different type of data and categories in data science. So let's get started. So in data science, we're going to make a review about the different data types which go through structured data, which are data that have predefined formats, unstructured data, with data without any formal structure, like for example images or speech or video files. And we have also other types of data that are semi-structured, and these are pretty much like JSON format, XML format, YAML format. It's something in between structured and unstructured. And also we will talk about big data. So I think most of you already heard about big data, because now with the emergence of internet and the data streams coming from maybe IoT sensors, from social media, from YouTube videos, streaming applications. So usually companies, they collect large amount of data, and the way how we handle this type of data in terms of storage, in terms of processing, in terms of analytics is pretty much different from the traditional data approach. Okay, so starting the difference between structured and unstructured data. So structured data, basically, it's as simple as a tabular form of data, like for example, CSV file or SQL tables. It's a data that can be displayed in rows and columns. So it's pretty much, it has a rigid structure. And we can store it in relational databases. So the good thing about structured data is that we can search the information quite efficiently and fast as compared to unstructured data, as we're going to see. And basically it contains textual data like numbers, dates, strings, anything that we can store into a relational table, for example, or in CSV file or documents. And this data, which is pretty much simple, it only constitutes like 20% of the whole data that is available on the internet. And this is where we have the challenge, because unstructured data is more challenging and it comes with much higher volumes, as you already said. So structured data requires less storage. Usually we can use SQL databases or relational databases to store this data, or simple Excel files or CSV files that can be sufficient to store structured data. And it's much easier to manage and to protect legacy solutions with structured data. On the other side, we have unstructured data which can come through multiple forms. So we can have audio data or speech data, MP4, MP3 files. It can be images, it can be emails. Emails also is completely unstructured. We don't have any rigid structure for emails. For images, so images, they can come up with different type of resolutions, with different type of sizes, different type of pixels. We can have RGB images, grayscale images, we can have thermal images. So there are different types of images, audio files, word processing files, like for example, Word documents, spreadsheets. All are examples of possible unstructured data. Yes?
Why are spreadsheets considered unstructured?
So spreadsheet, they consist of tables, but the document itself is not a table, it's a document. So it has some kind of binary code inside this document in order for you to be able to open Excel sheet, for example. Okay, it's programmed in C language. It's not just a raw data that you're opening.
But
Okay.
CSV file is structured, or
CSV file, it's structured, but it will be stored into, it will be opened by another application. So the file itself is not structured. The data inside is structured. Okay, when we talk about an application, a software is unstructured data. Okay, it usually comes as the form of a binary file. But the data inside can be structured or can be unstructured. Okay, and this data that is unstructured, it constitutes, estimated to be 80% of the enterprise data, and this is normal because usually the size of these files, of these documents, is much higher than a textual document. So usually text, it doesn't require too much storage. Okay, so for this reason, we need to have much higher storage for unstructured data, and it becomes more difficult to manage and protect this type of data with legacy solution, because initially when the internet started, it started only basically with textual data, and with the time it has evolved to different type of forms, okay, that can be exchanged over the wires. So in this slide, we're going to explore one type of unstructured data, that is sequential data. And sequential data, it means that the order of data points is important, okay, because we have a sequence. When we have a sequence, so we have a list of an ordered list of data points. And this data can be of different types, like for example, audio waves. This is a classical example of time series data, okay, because it's going to be organized as a sequence. Also the text, okay, the text, we have a logical order between the words. So if you take a sentence and you formulate it with a sequence of words, if you change the sequence or the order of words in the sequence, you're going to have maybe non-meaning or a different meaning. Okay, so the order of words of the data points is important. Also, electrocardiogram, which we call also the ECG data, which monitor and measure the electrical activity of the heart. So you know that the heartbeats, the difference between the heartbeats, okay, it's an important feature that can help to monitor the heart health of particular individual. So this type of data can be also analyzed. We can extract their features to perform some possible task, either using statistical analysis or machine learning and predictive model, as you are going to learn in this course. Also images, images is basically a grid of pixels. But in some of the cases now, for example, in the recent trend of AI and generative AI, and this is what makes the transformation of artificial intelligence with the technology that is called transformer. So transformer, basically, it was applied initially to the text, which has a sequential nature, and then it was applied also to images. So instead of considering an image as just a two-dimensional matrix, we're going to divide the image into patches. And we are going to organize these patches as a sequence. For example, the first paper that is called Vision Transformer, it has organized the image into 16 patches, and they are numbered from 1 to 16 in order to identify the features using the transformer technology, which basically requires a sequence as an input. Okay? So videos is also considered as a sequential data, because a video is what? It's just a sequence of frames. And this helps in several types of applications, like for example, behavior analytics. Behavior analytics is used in surveillance. For example, if you want to detect if a person is going to make, for example, to steal a house or make a danger to another person, for example, trying to kill another person. So how can we analyze? Usually we cannot analyze on one picture. One picture is going to give you only one single instance. However, an activity, a behavior, is basically a sequence of pictures where we can understand what kind of activity is going to happen. I will come to you. So in this type of applications, we're going to rely on a sequence of frames to be able to identify objects in different frames, and then try to infer from the features of this sequence whether there is a dangerous activities like an intrusion or a harmful activity that we can detect in advance. Yes, Sayed.
Doctor, can you please explain transformer again?
Okay, so transformer, this is one of the latest technology, okay, latest from 2017, but this is like the milestone technology that was proposed using neural networks. So in the previous lecture, I explained to you convolutional neural network, which uses convolution to automatically extract features. And for sequential data, there are recurrent neural networks. I've talked about briefly about this, because recurrent neural network, it has a sequential nature, so it will take the words or the elements in the sequence one by one. And then transformer, basically, it considers a sequence, but instead of taking the sequence in sequential manner, is going to take the sequence all at once. Okay, so it's a new type of architecture that is called transformer, that will process sequential data all at once, like we use the input of a basic neural network. You remember a neural network, we have features. We plug all the features at once and we do the calculations. So we're going to take a sequence of a predefined length, and this is why, by the way, ChatGPT, it has a fixed context length, so you cannot write text beyond a certain length. It started with something like 4,000 tokens, and now it's expanding to 128,000 tokens, but it has a fixed length. So this fixed length in ChatGPT, which is based on the transformer technology, it tells you the length of the sequential data that you can provide in the input. Okay? Yes, so transformer, usually you're going to learn it in advanced courses like deep neural networks, inshallah, but this is just a brief information. Any other question?
It depends on attention.
Yeah, the self-attention mechanism that was introduced with transformers in order to extract the features. It's just one of the ways to automatically extract the features like we've done with convolution. Yes?
I have a question, but it's about the structured and unstructured data.
Mm-hmm.
How do we integrate insights from structured data and with structured data? How do we integrate insights from unstructured data with the structured data sources?
What do you mean extract insights based on both type of data? What do you mean with this?
Like we get insights from unstructured.
Yeah, usually there are
we try
data.
to integrate it with that data.
Yeah, usually there are data analytic tools that are able to process structured data, like for example, SQL queries. They are able to fetch data, and we have also Panda frames in Python with some additional data analytics that are able to make processing of structured data. On the same way, there are other tools that allows you also to transform unstructured data to kind of structured format through matrices and vectors, and then do required processing onto that data. So basically, at the end, everything that you process in AI, whether it is structured or unstructured, it's going to return to a vector format. Okay? So we're going to transform any kind of data to a vector of numbers, and this vector of numbers will be processed through kind of linear and nonlinear transformations in order we get to predict the output or create a certain predictive model. That's, in very general, but we're going to dive this into more details as we go further in the lectures. Okay, so also we have other type of data is called genomic sequences, which are known also as the DNA. So the DNA is basically a sequence and helps to provide different types of information in bioinformatics, like, for example, identify the genetic markers and also develop personalized medical treatment for the patient based on their DNA. Okay, so I'm introducing Python. Next lecture, we're going to start with Python. So I assume that some of you are already familiar and probably some are already new. But even if you are not familiar, Python is the easiest language on earth. Okay, so don't worry about this. If you know Java, if you know C or C++, Python is going to be much easier to learn. And so this is an example of structured data that we can define. This is JSON format, and we can use Panda frames, for example. This is one of the libraries that we are going to introduce. Okay, and you can see that in this structured data, we have a very clear, a very rigid structure that is defined by the number of rows and the number of columns. So it's basically highly organized, and it can be stored in table or in databases. And it has predefined number of rows and predefined number of columns. And one of the tools that we will use in Python is the Panda frames, okay, to, for example, make descriptive analytics, like calculating the mean of the age or searching for particular type of information. So pandas provide a lot of useful tools in order to manipulate the data that has a structured format. And it's pretty much used in different industries and applications, like in the finance, we can use tables, SQL tables or CSV files to manage transactions, to store accounts, balances, and customer details. In healthcare, it can be used to maintain patient demographics or medical history, writing medical reports or treatments for the patient. So the advantage is very simple. It doesn't require a huge storage resources and can be easily manipulated with SQL or relational databases by making queries and analyzing the data and providing reports. So that's another example, but on unstructured data, which are images. And this is a very simple Python code that loads a JPEG image and visualize it using another library that is called Matplotlib. We're going to have lectures about all these different type of tools. And we can visualize, so this picture, it's an RGB picture, So all of us, we can see that this is a cat picture. But what is exactly this cat picture from data structure perspective? So you all have taken a data structure course. So basically this picture is going to be mapped into three matrices, two-dimensional matrices. One that represents the blue color or the blue channel. We have the red channel and the green channel. So the overlap of these three channels is going to give you exactly this image as it is colored. And what is the background here? White. And if we look at these three pictures, we have here strong blue, strong red, and strong green. So this is like the highest value, 255, 255, 255. If we stack all these 255 all together, this is going to give the white color. And you can see now, this is the blue channel, and this is the histogram showing, because every channel is basically a grayscale image between 0 and 255. Look, the scale of the image is a number between 0 and 255, and you can see the concentration of the blue here. You can see the concentration or the distribution of the red in this matrix, okay, and the concentration of green in this matrix. Yes?
I was going to say the 255 scale.
Yeah. This is the 255 scale. And here we have converted the image into a NumPy array. So of course, one of the things that you are going to learn is the NumPy array, which is a very, very powerful data structure that can make different types of linear algebra operation, matrix multiplications, dot products, sum of matrices, and eigenvalues, eigenvectors quite easily. Okay? And so we can convert the image into a NumPy array, and then we can use matplotlib and these type of tools in order to make visualization. Another type of unstructured data, as we already talked, is the speech or the audio waveform. So what are the features? How do we characterize a feature in this waveform? Is basically using the intensity or the amplitude and also the frequency. Okay, so this is like a speech I've done about hello world. So if everybody talks hello world, we're going to have similar type of speech pattern. Not exactly the same. We cannot make one-to-one comparison. If you speak hello world, it will be completely different on the way how we speak it. Okay, so we will have, if we speak it 1,000 times, we're going to have 1,000 different waveform lengths. But they share the same feature. So the objective of data science is, regardless of the differences inside the signal, if they share some common patterns, we are able to identify these patterns and make prediction. For example, now, how can we make speech recognition? We can convert speech into a text. So this speech model were trained on maybe native English speakers. But now usually if you say it with your voice, it's able to decode the text with high accuracy. Okay, of course, because there is a huge amount of data, and at the end, when the predictive model converge, it will become so very robust with respect to the unseen type of data. Okay, so it will be able to recognize most of the different type of accents. Okay, the model will become generalized, and this predictive model will be able, okay, to develop algorithms or solutions in order to be to identify the patterns that will come in each waveform. It's not only also speech recognition, there is also emotion. So if you hear someone speaking, you are able to say whether he is happy, whether he is neutral, whether he is sad. So you can make sentiment analysis also based on the speech. So we can derive other type of models. We're going to look at the pattern from a different perspective, apart from the phonics that you want to extract. Okay, so this is very important to build different type of models. Okay, just to extract the features that will help to teach a particular model about this. And now with machine learning model, we don't need to find a predefined set of rules, okay? But we're going to provide labeled or supervised learning in order to teach a model. For this voice, it means this phonetics, or this is positive, this is negative. With the large amount of data set that we're going to use for training, is going to converge to a very high accuracy, even on unseen data. And here, just in Python, we're going to use this is librosa library, which is used in signal processing, and matplotlib for visualization. So this is one of the works that we have done here by signal processing of the vibration sensor. And basically this was done also with undergraduate students who worked in our lab. So they co-authored with us this paper. And that was back in 2019 where we were working on red palm weevil early detection. You know, red palm weevil, this is one of the most dangerous pests on the palms. So basically this is a small weevil that will go inside the palm and start eating from the inside. And the problem, there is no sign. Okay, so it can stay there a couple of months until the palm becomes dead without even noticing this in advance. So the objective of this work was to identify some signal processing techniques based on the vibration sensors to be able to detect the presence of red palm weevil inside the palm, so the farmer can take preventive actions before that the palm actually die. Yes. So in this case, you can see now we have put some vibration sensors and we have analyzed the signal before and after. Okay, so the blue, it was before, and the orange was after the insertion of the red palm weevil. So there is a signature that we can, but of course, we cannot, okay, this is a visualization that can tell us whether there is a difference, but in this work, we have developed some advanced signal processing techniques based on Fourier transform and also on DSP techniques in order to be able to distinguish clearly between the two types of signals. So this is an example of the use of vibration sensors to predict, okay, and it can be used in real-world applications that have very important impact on the economy and also on the society. This is another Python example about the electrocardiogram signal as a sequential unstructured data. So this is a simulated signal. So in Python, there is a library that is called NeuroKit2 that allows to process ECG signals. And one of the utilities that exists there is to simulate an ECG signal, like in this one, for example, we specify the duration between the heartbeats and the sampling rate, the frequency, and also the noise. And based on this, it will mimic the heartbeat. And of course, this is very important in healthcare monitoring with patients because the pattern of the heartbeat can identify whether a certain patient has actually a disease, okay, a heart illness, or not. Of course, there are several ways on how to analyze this, either using statistical techniques or also signal processing techniques, or also now, most recently, machine learning and deep learning techniques to analyze. And the use of AI in healthcare is really very, very popular. So we use artificial intelligence neural network to identify, for example, diseases like cancers from X-rays or from CT scans. Also, we can apply them to ECG signals and different type of input data as well. Okay, so were some examples about structured and unstructured data. And now we come to the semi-structured data, which comes over two forms. There are also a third form that's called YAML. So either JSON or XML. So why we call them semi-structured? So actually they share some commonalities between structured because they have kind of structure, and unstructured because they don't have a very rigid structure. So their structure is flexible. What does it mean? So it means, and this is why JSON is used in what we call NoSQL databases. Have you heard about NoSQL databases? So SQL databases usually define a table with a very rigid structure. You have a certain number of rows and certain number of columns. And especially the number of columns should be fixed. You cannot add any additional information apart that what you have already defined in the columns of the database. So in MongoDB databases, for example, which is NoSQL database, which is semi-structured, we're going to store these records not as a table, but as a JSON documents. And this JSON document, for example, this one, it represents the information about the student. So we have a student with her first name, last name, nationality, university, and different type of things. So imagine that I want to add another information to the student. For example, I want to add the address or the mobile phone. In SQL databases, what you have to do? You have to change the schema of the table. You go to the schema of the table, change it, and then you'll be able to add that element. And maybe you need to have the mobile phone. You don't have the mobile phone for all the elements. Maybe only a few elements will have a mobile phone or an address or a particular type of information. And now, in MongoDB or NoSQL databases, there is no schema. If you want to add it in a JSON, so I can have a JSON of a student record that contains a mobile phone, and another one doesn't contain a mobile phone because there is no schema. They may share some common information, of course. Any kind of data, it will share information with different records, and it can have specific information. So in this case, you don't need to make any change because there is no schema. From implementation perspective, we can turn a NoSQL database in an SQL-like database. We can actually enforce a certain schema using, in Python, we call it the pandatic models that allows to define a certain structure for NoSQL databases if we want to make it structured. And this is the counterpart of the student record in XML format. And these two representations are heavily used in the exchange of data through the internet. If you want, for example, to send, imagine that you have a database that contains student records. If you want to send an information from one server to another, even from an SQL database, okay, usually we're going to structure this data as a JSON so that we can exchanging between two remote computers on the internet. So JSON and XML, these are the two popular. JSON is more popular because it is less verbose than this one, so it consumes less bandwidth if compared to XML format.
It consumes less what?
Less bandwidth on the network. Okay, so this is why JSON is more recommended than XML, although both are possible. Okay, because there are tools on how to recover the data, because this is basically a key value pair. So every key will correspond to a certain value. Okay, so let's finish this lecture with introducing big data. Okay, and big data refers to the large-scale data sets that are very complex. Okay, they contain a mixture of different type of data. It can be structured, unstructured, semi-structured, and usually big data they require advanced processing tools. So traditional tools are not sufficient to efficiently handle this data. And this is because, so big data is characterized by what we call the 4 V's: the volume, the velocity, the variety, and the veracity. So the volume, because in big data we have a massive amount of data. So data can come from different type of sources. It can come from IoT devices. You know, if you have IoT sensors, they will send information every 2 seconds, every 3 seconds. So you can imagine the scale. Imagine that you have millions of sensors, for example, for agriculture, or from temperature, or from indoor monitoring. So they will keep sending information all long time to the servers. So we need to have a way on how to process this data. Streaming applications like YouTube, social media. So imagine how Twitter generates data every second, every millisecond. Facebook, okay, Instagram, pictures. It's even more challenging. And all of these, they will come to the servers, and the server need to analyze this data. It's not just you submit something is going to be stored into a database. This is going to be processed in real time. It will be indexed, so the retrieval can be made fast. So it will also go for sentiment, and everything that you write, it will be analyzed. The first analysis, it will make a profile of yourself. So they know what are your interests, so later on they will make a recommendation system based on what you write on the internet. So this recommendation system cannot be efficient without processing this data in advance. So, and this data is processed in real time for every user on the internet. So you can imagine the scale. So we don't only have a volume, we have also a velocity, which means the speed or the rate at which the data is coming to the servers. Okay? How many megabytes we're going to have each second, or maybe gigabytes coming at the server at each second. Okay? You can imagine how many people are writing now on social media. It's almost all around the clock.
Trillions.
Yes, trillions of data is coming, and it has to be processed instantaneously. So traditional systems, they are not able to cope with these requirements. We have a variety of information. You don't only have text. You have text, you have videos. TikTok is basically videos. Instagram is basically pictures, images, videos, and so on. So you need to cope with these different type of data, structured, unstructured, semi-structured. And the veracity, okay, the uncertainty of the data quantity. This data quantity is going to change over time. It's not constant over the time. And for this, there have been several solutions that were proposed. So big data, I remember that it was like the peak in research back in 2010, 11, 12. So people started to talk about these technologies. And there are some solutions for the storage. So storage is one of the issues. So SQL databases are not sufficient to store unstructured data. And we have Hadoop, which is a distributed storage and processing using the Hadoop distributed file system. So HDFS is used actually to store large volume of unstructured data. So this is a particular type of storage architecture that were proposed to deal with large volumes, with the volume in the 4Vs. And on the other hand, you have the NoSQL databases, like for example, MongoDB, CouchDB, Cassandra. All these are some information of NoSQL databases that allows to store databases without requiring to have a very rigid type of structure or schema in advance. So MongoDB, this is one of the most popular examples. It's a document-oriented database designed to store high volume of data. And it's basically used JSON as a format to store these data as JSON documents. Cassandra, on the other side, is also NoSQL. It's highly scalable, and it was designed for the storage of distributed database. And this is very important when we need to have scalability and also fault tolerance. So what we do replication of data on different sites. So for example, if there is an earthquake here, we don't lose the whole data. We can make a replication. Okay, so this type of distributed storage is managed by advanced systems like Cassandra in order to maintain data consistency. You must make sure what you have data here is also replicated. It should not be different. It should be the same at the same time. Okay, at any time also. And data lakes, this is like an extension of data warehouses, but applied to unstructured data. So other type of big data technologies is the processing frameworks. So here we talked about storage solutions, okay, how to store big data, and also we have processing solutions. And there are different types of frameworks, like the MapReduce. It's a programming model. It's available in Python, in Java, in different types of languages that you use for processing large data sets in real time with distributed algorithms on different clusters. When you have a large amount of data, you cannot process them on a single computer. So what you will do, you're going to make the processing, you distribute it on different clusters. Okay, this is what we call map. And reduce, we're going to aggregate the solutions that will come from different clusters. Okay, so this is MapReduce. Apache Spark, this is for data analytics. Okay, that will apply on a huge amount of streaming data that comes from the internet. Okay, it uses data analytic tools like we're going to learn about pandas, matplotlib, but it's a complete system that is able to manage sessions in order to receive data in real time and process it as it comes. So we can define pipelines that will take the data from the input. Maybe you need to add a data cleaning phase, and then processing phase, you calculate averages, you calculate filtering, you will do any kind of operation. And then maybe you want to make storage, you want to make recommendation, adding AI or machine learning algorithms. So it allows you to define pipelines for a particular session of incoming streams. And Apache Flink, so this is used to offer stateful computation over data streams and provide high throughput and low latency. And there are so many others. This is just a very small snapshot about the technologies. This is a Python example about Apache Spark applied on a simple sales database data set. Okay, so here is an example of pipeline that we can define. Okay, it will perform the grouping per category. I didn't show here the data set, but we have 3 or 4 columns. So, for example, it will make an aggregation. Imagine that you have a big let's say like Amazon, having transaction every second or every millisecond, and you want to have real-time information about, for example, the total sale in every category, so you can take appropriate decisions whenever needed. And this is another one also for processing, streaming data over the internet. Okay, so that's all for today, and this is the end of the first chapter about finished with data categories and data types. So starting from tomorrow, we're going to start learning about Python, programming language. I will start with an introduction and then going into the data analytics and data structure and data analytic parts.